This video is going to show you how you can create new variables in SAS. If you're looking to translate this from SPSS, we had a couple commands in SPSS. So transform compute and then transform recode, both into the same variable and into a new variable. So we use transform compute to compute, for example, a logarithm or round a number or strip off the month part of a date. We use transform recode to group values into bins. So that's what we're going to be doing in this video, but I'm going to show you how to do these things in SAS. So I'm going to start out with the set command. So the set command is going to be extremely useful to us. What set does is it sets an existing data set into the current one. And we're going to do this for a couple reasons. So for example, one is that we may want to make modifications to some existing data set, like add the logarithm of some variable. Later on, when we get to different types of merges, we're going to be using the set command to stack data sets on top of one another. So this would be the equivalent in SPSS of merge, add cases. So the data merge add cases command. We're also going to use it to make a subset of a data set or sample. So that'd be like data select cases. Although you can also use the where statement for that. Okay, let me give you the basic outline of a program. So, for example, let's say that I have some library. I wrote this using my my PC at one point. What you probably want to do is bring in any user-defined formats that you have. If you don't have any user-defined formats, then just ignore that statement. And then the third thing you want to do is transform the variables. So let me try to explain to you what's going on. Data new means make a brand new SAS data set called new. Then what we're going to do is set this data set. So eddata.mydata. So my data is an existing permanent SAS data set. What we're going to do is just drop that data set into this other data set new. And we're going to do it one line at a time. So just put the first line in, the second line all the way to the bottom. Okay. Then we're going to include a bunch of statements that do our transformations, do the recodes. I'm going to put all those here and then run. So the way to think about this is you're going to set this one line at a time and then do these transformations one line at a time. Let me also mention that you can do these things like the transform computes and the recodes when you're reading in data, but usually you want to read in data once and that's it. But just to show you, let's say I read in case12.csv. I brought in the 5 variables. Then if I wanted to compute, for example, the logarithm of density, I could just add another line here. Log density is the log, so capital LOG is a reserved word in SAS of density. If I want to find the square root, well, take the square root of rate. And I could have any number of statements here and then run. So let's take a look at another example. So I'm first going to read in my data. You've seen this program a couple of times by now. So we read it in and we print it out. Cool. Now, let's say at a later point, I want to make some modifications to this. So I'm going to make a new SAS data set. Let's call it new data. How am I going to make new data? Well, I'm going to set my data. So my data is that thing I just read in. And let's get rid of color and amount. We don't really care about those two variables. So this parenthesis business gets rid of those columns. It'd be like highlighting the column and deleting it. Then I can list any number of transformations that I want to take. So x squared is going to be x star star x. Star star is the exponentiation operator in SAS and in SPSS, as I recall. then the log of y, and so forth. So if we want to print out what we got, okay, well, let's see. X squared, 1 squared is 1, 3 squared is 9, cool. The logarithm of y, looks like that worked as well. So hopefully you can see how, when we print new data, you see how we've dropped a couple of the columns and computed 2 new ones. Now, another thing that I can do is overwrite a data set. So let's keep going. This is one grand program. Let's make a new data set called new data, and we're going to set the contents of new data in there. So it's going to drop it in one line at a time, and then let's compute something like the square root of x. So there's the square root of x. Cool. Notice we just printed new data down here. So let's now talk about the types of things that you can do either after a set command or after you've executed an input command if you're doing it as I had up here. So what can I do? Actually, before we do that, I forgot to mention there are a lot of data set options, more than I want to list here. This is a small subset of those. See the SAS manual, you just Google SAS data step or data set options, and you should get an entire list from the documentation. So here are some. If you set a file and you say obs equals, for example, 100, then that would only set the first 100 observations. So I mentioned this to you last time, but in the context of an in-file statement, when you're debugging a program for the first time, you don't want to set the entire data set if it's a very big data set, because that will use a lot of computational resources and waste your time. So if you just put the first 100 observations, get the program working on the first 100 observations, then you can get rid of obs equals 100, and you can do it on the whole thing. We will be using in equals when we get to merges in about a week or two. Sometimes you don't want to keep all the columns, you just want to keep certain columns, so you can list a whole bunch of variables here. I've given you an example below. If you say set my data, keep x and color. That means I just want to keep x and color, forget the other variables. You saw an example of that on the previous page. Actually, you saw an example of drop, where I drop 2 columns. So drop is just the opposite of keep. So you can also drop variables. Sometimes you want to rename them. Here's the syntax for that. Sometimes you don't want to keep all of the cases. You can stick a where statement off of set as well. So in my example below, you're going to see I'm only going to keep cases where x is greater than or equal to 3. Finally, you can do an obs, and we're going to be doing that once we get to our sampling lecture. So these are all the different, these are all the different things that you can do as set options. All right, and you can include these anytime you reference a data set. So here's a proc means. We drop the freq in the type variable sometimes, and so forth. All right, now let's talk about all the different types of computations that you can do. So these assignment statements are the equivalent of transform compute in SPSS. So here's some basic assignments. You don't have to say compute as you do in SPSS. You just say female equals 0, and that assigns the constant 0 to the variable female. Dollars equals dot assigns the value missing to dollars. Maybe area equals length times height, so we use star as the multiplication operator. We could add up values, so total is just the sum of Monday plus Tuesday and so forth. Could do division with a slash. You can include parentheses. So this would mean add up a, b, and c first, then multiply by y, store the result in a variable called x. As I mentioned to you a minute ago, star star is the operator to do exponentiation. So this would be the n divs squared would be tran1. Now, in addition to these basic assignment statements, we can also use functions, and there's probably over 100 such functions. These functions are very useful. Here are a limited, set to kind of show you some of them. Square root, log base 10. If you want to find the sum of a bunch of numbers, this is identical to what you have in SPSS. You just say sum x1, comma, x2, just list the variables. We can also end up using dashes or double dashes. If you want to do that, you have to use of. So if you say sum of x1 dash x10, that is exactly the same as the line above. Likewise with mean, max, range, standard deviation. We can compute random numbers. So ran uni is a function that will return a random number between 0 and 1. The number, the argument that you pass to this is called the seed, and that determines the random numbers, if you will. We're going to talk more about random numbers in a couple of weeks when we get to the sampling module. Month strips off the month from a date variable. Day strips off the day of the month from a date variable. Weekday would strip off the weekday, so one would be Sunday and so forth, just as an SPSS. And I'll talk to you about substring and length in a minute. Let's do a little example program now. So there's a lot to illustrate here. We've got a little data set with only 3 lines. The first variable is going to be name. So we got 3 people, Mike, Sally, and Ann. We're going to read in 3 x's, x1, x2, x3, and we know their birthday. Notice I use the in format statement to tell SAS we're going to input birthday as month, month, day, day, year, 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 year. So there's 10 total characters, so that's why it's month, month, day, day, year, year, 10 dot. All right, let's just compute some new variables. So sum x will be just the sum of x1 dash x3. Let's find the mean, find the max. And if you look below, we printed it, and hopefully this works. So if we take the sum, 2 plus 4 plus 6 is 12. Cool. Divide that by 3, you get 4. What's the largest? Well, it's 6. Now, if you want to do date arithmetic, so today happens to be March 4th, 2012. So if I want to find out how old somebody is, if I take this date constant, that's today, less their birthday, then if I divide by 365.25, the 0.25 captures leap years, I'm going to know their age. So let's go see what their ages are. And so Mike is 52, Sally's 31, and Ann is only a year old. So that looks right. If I want to strip off the month, I just use the month function. So Mike was born in January. Looks like Sally was born in October, and Ann was born in December. All right, let's talk a little bit about some very basic string functions. We're going to have a lot more on string functions later. The length function is going to return the number of characters in a string. So let's go look down below. Mike is composed of 4 characters, so the length is going to be 4. Sally has 5, so the name of her length is 5. Ann only has 3. A few more things. Substring. So what substring does is it extracts part of a string. So translated into English, this says, take the string name, start in the first position and extract one character. So this would be a way to, for example, strip off the person's first initial. So I want to know their first initial. That means go to their go to name, go to the first character, and take only the first character. So over here you'll see Mike's first initial is M, Sally's is S, Ann's is N. Now I also decided to generate a random number. So we're going to use this for sampling. You'll see that this just generates a random number between 0 and 1. So that's a nice little example. Make sure you really understand what's going on there. Another thing that we can do in a data step is if then else. So note, all of this goes into a data step somewhere. On the next slide, I'll give you a more concrete example. So for example, these are all valid if then else's. If cn dal greater than 35, then tran1 equals 35. So what I'm doing on this is I'm capping it. Any values greater than 35 will be set equal to 35. Otherwise, else, tran1 is just cn dal 1. So any value less than or equal to 35 is the original value. Anything greater than 35 gets mapped to 35. We can also do things like this. So if or date is less than or equal to this, and or date is greater than that, so if it's in a window, then we're going to go do some computations. Okay, if amount is greater than 500, then do something, else do something else. All right, let's go look at a little more detail about logical expressions. So we can say if x equals something, we can also say not equals. So NE is not equals. Greater than, you can also abbreviate that as GT. Less than is LT. Greater than or equal to, you can say GE, or you can say greater than or equal to. One of the real useful functions in SAS is the in function. So if you could say market in, that means if market is any of these values, 1, 2, 4, 6, or 9, then go do something, otherwise don't do it. If you don't want it in, so if market is not one of 7, 8, 12, or 15, then do something. Another very useful command is just say if age less than 50. What this means is you're going to keep all records where age is less than 50. Anything that is 50 or more gets deleted from the data set. Now you can also include words like and. So this is satisfied if type is 4 and market is in one of those groups. Or is if type is 4 or this. Either one of those conditions gets you into the data set. You can put parentheses. So if CRNE equals 1 and type equals 4, or stage equals 2, then do something. You can have multiple elses. So if amount is less than 20, then amount 4 equals 0. Else, if it's less than 50, then put it into bucket 1. Else, if it's less than 100, put it into bucket 2. Otherwise, put it into bucket 3. You can also do sandwich expressions like this. So if age is between 13 and 35, then assign them to Gen X. Otherwise, they're not in Gen X. Beware, missing is less than 0. So if a value is missing and you say, if this variable is less than 0, that's going to evaluate to true. And so sometimes you get some unintended consequences where, so beware of that. A select statement can be used instead of an if then else. So in this select statement, what I'm saying is, all right, if the variable A3 is equal to 1, then set A3 num to 0. If A3 is equal to 2, then you're going to set A3 num equal to this expression. if A3 num is equal to 3, then set it equal to this, and so forth. And I could have done this with an if then else, but this select statement is a little bit maybe easier. So here's a little example program. Let's take that Siegel data set, and I'm going to do two things. Let's make some dummies for training level. So I want to make a low training level dummy. So if training level is 1, then we'll set low train equal to 1, otherwise low train is equal to 0. Then I'll make another dummy called medium training. So whenever training level is 2, then medium train is equal to 1. And let's put age into buckets. And you can see the result below. And I think I did everything correctly. Here are some problems for you to practice on.